Good morning, everyone. It's Coach Fred here, and today I wanted to take a minute to go over some challenge problems with fractions, specifically because I saw some errors. Not really errors. I saw some things that you could have made easier just by thinking about what we've been learning in class. So let's look at this first example that was on the challenge packet. You had x over x plus 3 plus 1 over x minus 1 equals 4 over x squared plus 2x minus 3. So first I would identify it's an equation. And then I would say, what type of an equation is it? It's rational, which means that I have some domain restrictions. We refer to those in equations. You could refer to them as a restricted value or your domain. I would then say that x could not equal -3 and x could not equal 1. Why? Well, if I plug those in, I'm going to get a 0 in the denominator, which we know that we've discussed. We can't have a 0 in the denominator because we get an undefined value. All right, then where I see some of us, a lot of you decided to just get a common denominator. But I want you to think about what we've been talking about all year with fractions. These are fractional equations, so clear the fractions. In order to clear the fractions, though, you'd need the lowest common denominator. To do that, this guy would need to be in factored form. Now, I actually think very hard about that when I'm factoring because usually these guys are going to be one of those factors. Not always when they get harder, but a lot of the time. And it just so happened that the right side factored to x plus 3, x minus 1. Again, this is not the only way to do this. I'm just looking at a way where we are using something that we've been talking about a lot in class. Okay, so now I'm going to multiply both sides of the equation. Remember, the entire equation by x plus 3, x minus 1, in order to clear the fractions. All right, so I'm going to come over here now. Notice my arrow pointing to where I'm going next. All right, so in the first expression, if I multiply it, I'll get x times x minus 1. Now, I always write that out. Some of you might jump to x squared minus x. I don't, because I don't like to make a mistake in case there's negatives. And there's a lot going on in that original equation. All right, plus, then the x minus 1 cancels, so I'm going to have 1 times x plus 3. And on the left side, everything cancels. They all cancel out, so I'd be left with just 4. And that already looks better, okay? All right, so I would distribute my x. And then I can see that these simplify to 0. They're opposites, and so I get x squared equals 1. I can use the square root method here. I can take the square root of both sides, but remember when we do that, we have to consider both the positive and the negative 1, because x squared, if I put in 1, I'll get 1. If I put in -1, I'll get 1. All right, so I get plus 1 and minus 1, and then I recognize that my restricted value is I can't have 1. So I'm going to reject this answer. I'm going to throw it out because 1 is not in the domain. So you can clearly kind of see that that took me, okay, maybe the factoring step, 1 step, 2 step, a lot less than some of you. Now, another way to do this, if you forgot the restricted values, would to take both your answers, plug them into the equation, and test it to see if it makes the equation true. But that actually took a lot of work. So I'm looking for this elegant, clean, efficient way of solving problems, okay? All right, now I want to look at the expressions because that's where I saw the most room for us to grow here. This summer, we asked a lot of you in terms of videos, but one in particular was about how to simplify fractions and what fractions are. And if you're still not clear on that, I think it might be worthwhile to go back to that. But this is called a complex fraction. Why? Well, because it's made up of a simple fraction in the top and then a simple fraction in the bottom, and then we've made a fraction out of those simple fractions. So you can do it several ways. You could find the common denominator of the top, find the common denominator of the bottom, and then divide what you get. But another way to do that is really to find the lowest common denominator of all your simple fractions. So meaning of this, of this, of this, and of this. All right, so the common denominator of all those fractions is 6. All right, so I'm going to multiply this by 6 and this by 6. Why can I do that? Because 6 over 6 is 1. All right, so if I do that, 6 times a half is 3. 6 times 1/3 is 2, and that would all be over 6 times 1 is 6, minus 6 times 1/6 is 1. And that would give me 5 over 5, which is 1. All right, so I want you to think about that, how much simpler. I want you to look at your work on the challenge packet. What did you do? Did you go the long way? Could you use this idea if we look at a problem like number 6? Okay, so I have a simple fraction here, a simple fraction here, a simple fraction here, here, and here. Well, you certainly could find the common denominators. Again, mathematics is sometimes about trying to find the most efficient way to solve things. And that number 1, that idea of multiplying by 1, when it looks different, can be really helpful. So I find the lowest common denominator of all the simple fractions. So in this case, that would be x squared y squared. So I'm going to multiply the top by x squared y squared and the bottom by x squared y squared. All right. Now there's a lot of little work here to do. I'm going to actually move vertically. It is really good to work vertically on these types of problems, on any math problem actually. Okay, so if I multiply x squared y squared to that, I'm going to get y squared. And if I multiply it to that, I'm going to get minus x squared. Ding, ding, ding. I wonder why that looks familiar to me. Okay, and then I'm going to multiply it across here, and I'm going to get y squared plus, so that was that, plus 2xy plus 2xy plus x squared. Ding, ding, ding. Okay, so why am I doing that? Well, because these are those special factor patterns that I talked a lot about this summer in your summer work, and they keep coming up. So this is dots, the difference of two squares. And I really need to get you starting to recognize that more comfortably. So that is y plus x, y minus x. Well, the bottom is that really important one I'm going to talk about a lot in our next unit, a perfect square trinomial. I call it a PST for short. That factors into y plus x, quantity squared, or y plus x times y plus x. All right, so there we can see that we're going to have some factors that we can cancel. We can cancel one factor of y plus x with 1 in the bottom, leaving us with an answer of y minus x all over y plus x. All right, so I really do want you to look at your work and determine if this might be something that you would do. Would you consider just multiplying by the idea x squared y squared over x squared y squared, the idea of the number 1? We're going to try it one more time on this one because this one's just a little bit harder. Each of those got a little bit harder. So again, I'm going to use the simple fraction and multiplying by 1. So I found the lowest common denominator of all my simple fractions, which was x plus 1 times x minus 1. All the factors, the most times they occur, x plus 1 times x minus 1. Okay, let me change colors to red. I'm going to multiply it to there and to there. So that's going to give me the x plus 1s will cancel. I'll get x minus 1. On the right, the x minus 1s will cancel. I'll get x plus 1. Don't really need to put that in parentheses because it's addition. On the left, I'm going to multiply and I'm going to get the x plus 1s will cancel. I'm going to get x minus 1. Got to be careful because that's a negative. So when I cancel the x minus 1s, I do need to put x plus 1 in parentheses. All right, now I can simplify. So it seems that the negative 1 and 1 are opposite, so they go to 0, and I'm going to get 2x in the top. I am going to distribute in the bottom and get x minus 1 minus x minus 1. So what happens in the bottom is the x's are opposite, so they simplify to 0. And so that gives me 2x all over negative 2. So negative x. All right, so that was just a quick review of some things these ideas I wanted you guys to consider. Likely will be on your test, so I wanted to make sure you had an opportunity to look at that if you can't come in to get extra help. All right, guys, have a great day.